Hey everybody, Michael here with RT Balls. Today we're basically just going to be talking about ball pythons and all of their genetics. We're going to be talking about allelic, recessive, codominant, and maybe hopefully by the end you'll know what the crap I'm talking about. Alright, so guys, first I pulled out this little girl right here. Now, most experienced ball python people will look at this and they'll say what? They'll say a normal ball python. This is a normal ball python right here. This is about as basic as you're going to get with the morph. Now a morph basically means a different kind of pattern, a different paint job on the snake. Like this is a normal, like stock basically. If you're talking cars, this would be a stock car. Now if you want to add a really cool pattern or something to it, then you go ahead and get something like this. Now this is a spider ball python. Of just patterning as well as coloring and other things. So this is a spider and this is a normal. So there's just different paint jobs in the industry. So basically when people go to get ball pythons, they go and get a normal just because of how pretty they look, as well as just how small and cute they look, you know? Well, when you get a ball python, sometimes, and most of the time, they grow really fast. So, take for instance this little baby, and in a year or two, or even a couple, maybe 3 or 4 years, they could turn into this. This right here. This is just a massive snake. Now, for most experienced ball python people, this might not be huge, because this is a male right here. Males tend to be a bit smaller than females, but this guy right here, whew, now that's big compared to that little baby that we saw earlier. And yeah, this is about average. This is how big they'll get. This boy right here is about 7 years old. Alright, so here is some pretty awesome paint jobs in the ball pythons. This is a pastel right here, which is just one gene, one genetic, just pastel. It's a codominant morph, which basically means if you breed a normal, 50% of the babies would be a normal, and 50% of these babies would be this beautiful little pastel right here. Now, that can always change. It could be 9 out of 10 babies could be a pastel, and it could be 1 out of 10 babies could be a pastel. That's just the average that you're looking at. Alright, so this was a 1 gene. This is a 2 gene animal. This is Enchi and Butter. 2 gene animal. It's a lot brighter. Now Enchi is kind of just a morph that really just reduces pattern. So instead of having all this pattern that you see with this pastel, it has a lot less going on around the sides and back and stuff. It has more of a stripe going down the back instead of broken up saddles like that. Alright, so now as I showed you before, I showed you this little girl, which is 2 codominant genes, Enchi and Butter. Now, also the pastel was also codominant, so that just basically means that 50% of the babies will be this and 50% will be normal if you breed them. Now that can always change if you're doing 2 gene to 3 gene animals. You can just mix in a whole bunch and you might not even get a normal in the clutch. So, right here we just have an Enchi. I wanted to show you this because mainly you can see the difference between adding another gene in. Like this is just added Butter in, and you can see the giant yellow bandings on this versus this where there's a nice amount of yellow but not intensely like this. And yep, this is a probably year-old Enchi right here. Now we'll get back to her because there's some interesting genetics going on with her as well. Not just Enchi, but that's all you see. She's actually 3 genes, but the only gene you see showing is Enchi. Now the reason that is because she has recessive traits to her as well. Recessive morphs. She has pied as well as ghost. So ghost is a hypoform, which is basically just lightens up patterning and makes it more whitish, like tannish sort of coloring on her. You can see a little bit of visual het on her as well. Visual het is what you would see with an animal that carries the gene but it doesn't show, like recessive. This is a recessive female, so she's carrying 2 recessive genes, which is het pied and het ghost. Now the heterozygous basically means that carries the gene but it doesn't show. She has 2 of those. So if I bred her to, say, a ghost male right here, or I bred her to a pied or a pied ghost, basically what that would make then is a pied enchi or a enchi ghost. And those are really pretty animals, and those would be 2 genes, but they would both be visual instead of just carrying the gene but not showing. So those are really interesting. Recessive is a great thing to get into when you're breeding because basically the prices never go down. They never do. I mean, pieds have been at $300 each, and they've stayed at $300 for close to probably 20 years now. Same with albinos and clowns, and we'll get into those in a second. But yep, she's het pied and het ghost, but she's also enchi. So she has 3 genes, but only 1 shows. So this is an actual recessive ball python that shows. It doesn't just carry the gene, but it actually shows. This is a clown ball python. Now he's in a ball right now, obviously, so he doesn't want to come out. So the coolest thing about him is his head, and that's a really, really cool recessive morph that can really do crazy things when added in with some more codominants or other recessive morphs. And then, right here, remember that normal that I showed you earlier? Well, she actually has another thing going for her. She's het clown. This is clown. This is a het clown. You see the difference? She's a normal, she carries the gene but doesn't show, and this is the actual gene. So basically you breed these together when they're older, and 50% of them will come out looking like this, 50% will come out looking like this, but every single animal in there will be clown. Okay, so right here, we actually have a pinstripe ball python. This is a codominant morph, which means, 50% will be normal and 50% will look like this when they come out. Now he's a really pretty chunky boy. I mean, he's a big boy. I got him probably a year ago now. This is how big he's gotten in a year. He looked like the little baby over there when I got him. I actually did not show you guys something, but the Mojave that I pulled out earlier, this guy, he also is het ghost as well. So possibly in the future, if I bred this boy to the enchi that was het ghost, then technically in the future you could get some ghost Mojave enchis, and that would be the whole 3 gene codominant right there. Well, actually, 1 would be recessive and 2 would be codominant traits. And then right here is obviously a codominant. Now an allelic trait is basically maybe 2 traits that look the same, and you breed them together, but only 1 can come out in each animal. There can't be 2 that would come out. Like if you bred something to something and they mated, but they're 2 different genes, they can't combine them. They're allelic. They can't combine, but you'll still produce babies. So 1 baby could be this one, and 1 baby could be this one, but there's no mixture that could happen because they're allelic.